In the last few articles, we saw how to make our Phoenix chat app distributed. At the beginning with Redis and after with distributed Elixir, connecting the nodes together. We had just one problem. We had to manually connect the nodes in the IX console. This is an issue in production. In this video, we will see how to automatically cluster the Phoenix chat nodes using the libcluster library locally and on a Kubernetes cluster with a dynamic number of nodes. Let's download at first the code of the Phoenix chat example from my account, Poetic Coding, and let's use the pub/sub pg2 branch. Okay, let's clone the code and check out to the pub/sub pg2 branch. Let's download the dependencies and try to run it locally. So we can pass the port as an environment variable. So the first node at the port 4000. Yeah, we give a name at the first node A, and we start the Phoenix server here, and we do the same also with this, name B and port. Okay, great. Node connect. Let's connect to B and BP, and we see that it seems to be connected correctly. Let's try the chat app with the two browsers. So let's connect with one tab to 4000 and the other tab with 4001. So 4001 is the node B and 4000 is the node A. So user A, hello, and we see that the message is propagated correctly, is broadcasted correctly to the other node. So user B, hello too. And we see that it works okay. So we had to manually connect the nodes using the connect function in the node module. Let's see how to use libcluster to automatically connect the nodes. So at first we need to add the libcluster library as a dependency. And let's add the libcluster as a dependency. We then need to start a cluster supervisor, which is part of the libcluster library, and with some topologies, and this is the name of our supervisor. So let's add a list of topologies. This is really simple. So we just say our topologies is chat, and we use a strategy, which is the gossip strategy, which uses multicast UDP to gossip node names to other nodes in the network. Great, and it should work straight away. So as before, we start one node, the A node on port 4000, and the other node on port 4001, the name is B. And you see that the node A is now connected to node B and vice versa. So node list. We see that we didn't have to connect them manually. The same if I add another node, name C, on port 4002. So they will connect both, you see here. So they will be now connected also to the node C. Node list, and obviously on node C, node list. Great, let's see if everything works on the browser. So this time we have 3 nodes, so localhost 4000, localhost 4001, and localhost 4002, which is the node C. So C, hello. We see that it's propagated correctly. A, hello from A, and seems to work. Great. The last one from B. Perfect. Let's now see how to deploy this distributed application on Kubernetes and making the clustering of the nodes, of the Elixir nodes, automatic with libcluster. So we are going to deploy multiple chat nodes on my Kubernetes local setup. But what I'm going to show you could work without any radical change on any cloud Kubernetes setup. We're going to deploy our chat nodes with a Kubernetes deployment and we will connect them automatically together thanks to libcluster and something called the Kubernetes headless service, which we'll see in a moment. We will then create a Kubernetes load balancer, which will spread the connections from different browsers to different chat nodes. So what is a headless service? I've put this file nginx cube test. You can find all this code under the libcluster branch. So let's try to see with a simple nginx deployment what is a headless service. We define it like this. So it's a service, but we specify cluster IP none, and the DNS will be nginx nodes under the default namespace, and the port in this case the target port is 80. And the container, so you see here the selector app nginx, so this service is going to target all the pods of this deployment. And you see the container. This is just an nginx deployment. So we have, okay, let's put, for example, 4 replicas. And yeah, this is pretty simple, normal nginx deployment. And this will point to these nodes. So as I said, I'm going to use my local Kubernetes setup. So I'm going to apply this. So what it does is it creates the service and it creates the containers, actually the pods. Sorry. Okay, we have 4 pods running, and we have our service, headless service. You see here the cluster IP doesn't have an IP. And to see what it does, we are going to use this. So with this, we run a pod. I call it, so this is the name of the pod we are going to set, bash. And this means that once we exit from the bash, the pod will be removed, will be terminated. And so this is actually an Ubuntu image, and we are going to execute bash. Okay, so this is a basic Ubuntu distribution, and I'm going to, so I need to do an update, and okay, I'm going to use, I'm installing DNS utils to have NS lookup, and I'm also going to install curl. So if we do NS lookup nginx nodes, we see the list you see here of all the nodes. If we scale out, for example, to 8 replicas, and we see our pods, so we have this is our bash that is still running, and our 8 nodes, nginx nodes, pods. And if we do another NS lookup, we see that we are able to list all the IPs. So at first, let's start changing the topology. So we use this strategy, so cluster strategy Kubernetes DNS, which will use the headless service we're going to create. And the service under service is the name of our headless service, so chat nodes. As we did before, before we had in the example Nginx nodes. And the application name chat. So what is this? When we start the interactive Elixir console, we usually pass s name, short name, and we pass a. So this actually the node, and then the node name will be a, and for example MVP, because my local host name of my MacBook is MVP. Since the pod has each pod has a different IP, we need to use the name option. And since the IP is unique, chat, we can put chat. This can be always the same, and obviously the pod IP, which is unique. So, and as before, we pass these topologies to the supervisor, and we initialize the supervisor with this name. We are going to do another change. So in the controller, so what I want to do is to know in which node we are connected. So self node is inspect node. And also the list of the nodes this node is connected to. So nodes, and is node list. And we're going to pass this to node is self node and nodes. So here is actually inspect. I'm going to print this. It will not be really pretty, but it works. So so nodes and nodes, and also my node, so self is, we call it self node. Okay. So no, actually this in the controller was self node, but as a parameter here is node. So the application now is ready. We need to build a Docker image. But before building the Docker image, we're gonna see first the headless service. So this is the headless service like before. So instead of the port 80, we are going to expose the EPMD, because this is the port we need to expose between containers. And this is the name of the headless service, and obviously cluster IP none. And we are going to create a chat load balancer. So we'll create, since we are going to use my local setup, I will have in my localhost the port 80 opened, and the target port will be 4000. 8000, and the target port will be 4000. And this 4000 is the port the chat nodes will open. So we're going at first to create 4 replicas, and so this is the image I've already uploaded. You can also build your image, as we will do together. The port is 4000. So this is an environment variable Erlang cookie. Each single node has to be started with the same Erlang cookie. So they need to share this secret. And this is, okay, this is really important. So we need to create an environment variable with the port, with the pod IP. And with this, we're going to use the pod metadata, which is the IP, and we're going to we are injecting this into an environment variable we can use when we start the application. You see here, the command is Elixir and these are the arguments. As we saw before, this is the application name and this is the environment variable, this environment variable, and this is the secret. So this is dynamic. We don't need to specify the pod IP. This is pretty useful. Actually, we need this because every time we reset the pod, every time we terminate a pod, a new pod will, Kubernetes will spawn a new pod and the IP will be different. And we started the Phoenix server. So let's see how to build the Docker image and then to deploy all this. So to deploy the Docker image is pretty simple. Docker image build T, so the name of my Docker image, so Phoenix, so locally, so this is the local name, Phoenix chat example, or since it's local, let's call it chat, and the tag is libcluster, and okay, this directory is the context. So we can actually use this image in our Kubernetes deployment. So here, instead of this, we can use this image. So to create all the resources, we just need to do kubectl. I use k is just an alias. K create and this file. So you see here it creates a chat deployment, a chat service, which is the load balancer, and a chat nodes service, which is the headless service. So you see here chat nodes and chat, which is the load balancer. So let's connect to the load balancer. Great. So we see so the nodes, the connected nodes to this node. So we have 4 nodes. This is the local node and these are the other nodes. Okay, great. And here I'm connected to another node. You see here. So for example, you2, hello. And you see here that I see the message. Hi there. And let's see if I take another tab. But this is another node again. User C, low O. And you see how the message is propagated correctly. Great, let's put 10 replicas, for example, and let's apply the change. And let's connect to, you see here, we have all the pods connected, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if we want to delete the resources created, we just have to delete all the resources in our config file. You see that the pods are now terminating and the services are deleted. We saw how easy it is with libcluster to connect the nodes together and deploy also on Kubernetes a distributed Phoenix chat application. If you have a question or something wasn't clear, please post a comment in the comment section below. And subscribe to be updated with new articles and new screencasts. See you next week.